is known Izzatul
My name is Arifan Beroslan.
My name is Sufyan Hakim.
Hi, my name is Adibna Kudiam Bezukipli.
Hi, my name is Nur Emil Huda binti Muhammad Yunus.
Milling machines evolved from the practice of rotary filing, that is, running a circular cutter with file-like teeth in the headstock of a lathe. Rotary filing and later true milling were developed to reduce time and effort spent hand filing. True milling machines were first invented in 1783 by Samuel Rehe. Milling machines went through numerous developments throughout the 1800s and 1900s and has evolved to the machines that we currently use today. So, what is milling? Milling is a cutting process that uses a milling cutter to remove material from the surface of a workpiece. The milling process removes material by executing many separate small cuts. This is accomplished by using a cutter that has many teeth, spinning the cutter at high speed, and advancing the material through the cutter slowly. There are a plethora of topics that we can cover in milling, but in this video, we will be covering about vice alignment.
Let's start with equipments and tools.
First, we will need a vise. Next, a mallet. The dial indicator, vise handle, your workpiece, some parallel bars, a wrench, and a file.
Let's switch on the machine. Wait for the control panel to boot up, then press any button. Next, we need to move each axis of the table till the ref stops blinking. Move the x-axis, then the y-axis, lastly the z-axis. Now we can start aligning the vise.
The first one, gather all equipment and tools that are needed. Second, clear all chips on the table, especially the slot. Third, mount the dial indicator. Fourth, place the vise on the table and lighten one side of the board. The table, take the other board. Clearly clamp a parallel bar using a vise, making sure the dial indicator properly touches the parallel bar. Move the x-axis on the table until the prop is closest to the making bar. 7. Move the y-axis until the dial indicates 0. 8. Move the x-axis to the other side. Use the mallet to tap the vise towards the lighting bulb until it touches the prop. 10. Vise again until the indicator is 0 and the main message is 0. 11. Move the x-axis back to the starting point and move the y-axis until the dial indicates 0. 12. Move the x-axis again. 13. Tap the vise again until it indicates half the prop initially. Step 11 and repeat for a couple of times on both sides 0. And make another pass to check that it is 0 from one end to another. Lighten the other bulb. Make a last pass to finally check that the button is properly aligned. Tighten both bolts carefully not to distort.
Purpose of doing vice alignment. It is important to line the vice up with the fixed X on the machine-to-machine features that are aligned with the stock's edges. Ensure that the mill head is perpendicular to the mill table's X and Y axis. Vice alignment ensures that cutting tools and the milling surface are perpendicular to the table. Proper vice alignment also prevents irregular pattern from forming when milling. A vertical mill head can tilt from front to back and side to side. Sometimes, the adjustment can drift. Lastly, it is to ensure that the spindle is perpendicular to the table.
In conclusion, vice alignment is an important step before you start milling your workpiece. In the setting up the vice onto the machine table, the fixed jaw of the vice must be set parallel to the machine table using a parallel bar and a dial gauge. Adjustment can only be made by using the height mallet to correct its position such that a near zero indicator movement is achieved at all positions along the parallel bar.
Thank you for watching.